March 11, 1945, 2 p.m. hours. Western Pacific. WWII Atoll. The anchorage of Task Force 58. Scorching heat. The air is so thick it feels almost solid. The sea acts like a massive, polished plate of blue steel, reflecting the deadly ultraviolet rays of the equator. The temperature has already broken 106 degrees Fahrenheit. This is not an environment fit for human survival, let alone war. Yet, anchored right here is the largest destructive force in human history. Pull the view up. Looking down from 3,000 feet, WWII Atoll looks like a sprawling metal metropolis. 15 Essex-class aircraft carriers, 8 Iowa-class and South Dakota-class battleships, dozens of Cleveland-class light cruisers, and countless Fletcher-class destroyers, buzzing like worker bees between the giants. Over 600 ships are crammed into this narrow lagoon. The black smoke from funnels mixes with the pungent smell of burning heavy oil, the exhaust of hundreds of carrier planes warming up, and the sour sweat of 100,000 sailors. The entire anchorage smells like a burning oil refinery. Now, push the camera down. Focus on a strangely shaped vessel at the edge of the anchorage. It has no streamlined hull, no terrifying 16-inch guns. It doesn't even have steel armor. It looks like a grey rectangular coffin floating on the water, its surface rough and lifeless. This is a special service vessel, hull number 9-150, codenamed Quartz. Its hull isn't steel, it's concrete. The thick cement shell is baking in the sun, hot to the touch like a firebrick fresh out of the kiln. This ship has zero offensive power. If a Japanese torpedo hit it, it wouldn't twist and warp like steel. It would crumble like a dry biscuit and sink to the bottom. But right now, to the cracked lips and longing eyes of the 100,000 sailors of Task Force 58, this ugly cement boat is more holy than Fleet Admiral Nimitz' flagship. Inside the hull, a massive roar drowns out the waves. It's not the sound of diesel propulsion, but the scream of compressors. 2 heavy-duty ammonia refrigeration compressors are running at full load. The sound vibrates along the concrete walls, making the floor numb. The pipes aren't carrying fuel, they're carrying liquid ammonia. The cargo holds aren't filled with high explosive shells, but tons of powdered milk, sugar, and vanilla extract. A shirtless mechanic, a soaked towel around his neck, stares intently at the pressure gauge. The needle trembles. Outside the condensation pipes, a thick layer of white frost forms, radiating an intoxicating chill. This cold air forms an invisible front against the 100-degree heat wave just outside the hatch. The mechanic pulls a massive lever, and the mixer lets out a deep growl. Thousands of gallons of mixture tumble violently inside stainless steel drums, rapidly crystallizing and hardening in the low temperature. 5 minutes later, a large metal valve is opened. A pale yellow, sticky semi-solid flows out, rich with the scent of milk. It's not explosives. It's not poison gas. It is ice cream. Every 7 seconds, it produces 1 gallon. This $1 million concrete barge is the U.S. Pacific Fleet's exclusive ice cream factory. Its mission is singular. On the front lines, just a few thousand kilometers from the Japanese mainland, provide unlimited frozen desserts to every passing American warship. Now, pan the camera to the northwest. Cross 2,000 kilometers of ocean. Rabaul Japanese base. The same time, 2 p.m. hours. It is also 100 degrees here. But here, there is no roar of machinery, only a deathly silence. A Japanese private first class, his face sallow, cheekbones protruding, eyes sunken like black holes. The Type 98 uniform on his body has rotted into strips of cloth, hanging on a skeletal frame. He is lying in the mud, clutching a cassava root he just dug up. This is his entire ration for the day. No salt, no sugar, not even clean water. Because American submarines have severed all supply lines, this Imperial Army unit that once swept across Southeast Asia has devolved into cavemen. For this single route, he nearly drew his bayonet on a comrade moments ago. If you told this soldier, who is gnawing on raw, bitter cassava, that 2,000 kilometers away, his enemy, the American devils, are complaining to logistics officers because today's ice cream is only vanilla, not chocolate, he wouldn't believe it. He would think it was the most vicious lie, a hallucination born of madness. But this is the fact. This is not just a gap in weaponry. This is not just a gap in tactics. This is a war between 2 dimensions. While one side worries if their next meal will be rat meat, the other has shipped an entire industrial assembly line out to sea, just so soldiers can eat something sweet before they go out to kill. This concrete ice cream barge, the Quartz, is the most tangible embodiment of this brutal contrast. It is a special shell fired by the US military into the Pacific theater. It doesn't kill people, but it destroys their will. In this story, we are not talking about the giant guns of the Iowa class, nor the air groups of the Essex class. We are talking about this mobile freezer. We are going to disassemble this massive, perhaps even absurd, logistical monster. We need to understand why, in that era of flying flesh and blood, the US Navy spent millions of dollars to manufacture this easily melting luxury on the front lines of a war zone. This is a story about steel, sugar, and absolute national power. A cold, hard proof that logistics is war. Pull the view back to WWII Atoll. A rust-streaked Fletcher-class destroyer is slowly pulling up alongside the Quartz. On the destroyer's deck, hundreds of sailors are lined up. They have just finished a 3-week radar picket mission. 3 weeks facing kamikaze suicide attacks and endless battle stations. Their nerves are stretched to the breaking point. Many have bloodshot eyes and trembling hands. But right now, everyone is silent. Their eyes are locked on the crane extending from the side of the barge. The crane moves slowly. Inside that massive canvas bag are 10 large stainless steel tubs. The sound of metal clashing echoes over the water. Thud. The canvas bag lands on the destroyer's deck. A sailor rushes forward impatiently and pries off the lid. White mist instantly rises. In that moment, the cheer that erupts from the deck is louder than the sound of shooting down a Zero fighter. It's strawberry flavor. The smiles on these young men, covered in oil and struggling on the edge of death for 20 days, are the most surreal and authentic images of the entire Pacific War. And behind all of this is an industrial system so precise it is terrifying. Let's rewind time. Back to where it all started. Back to the moment of the decision to turn sweetness into a weapon. This wasn't just for appetite. This was a carefully planned morale experiment. The US Navy wasn't always this extravagant. In the early days of the war, they too experienced chaos and shortages. But late one night in 1942, in the Navy Department building in Washington, a report on frontline psychology hit the desk. It stated, during long sea deployments, soldiers' psychological defenses were collapsing. Lack of entertainment, lack of alcohol, lack of women. Monotonous killing was making sailors irritable and inefficient. They needed a legal, mass-producible stimulant that could bring instant pleasure. Thus, a project codenamed BRL was launched. Barge, refrigerated, large. It sounds like a boring logistical term, but its essence was a floating island of bliss. We must understand the logistical background of the time. The Pacific theater was completely different from Europe. In Europe, you could capture a city and use local ports, railways, even bars. But in the Pacific, there was only vast blue water and desolate coral reefs. More than 6,000 nautical miles from the San Francisco logistics base. Every drop of oil, every bullet, every mouthful of fresh water had to be transported across half the globe. Under such supply pressure, shipping milk powder and sugar for ice cream seemed, by traditional military logic, like a crime. Every ton of milk powder meant one less ton of explosives. Every cubic meter of freezer space could have been used to store blood plasma or penicillin. But the US top brass made a shocking calculation. Without ice cream, morale drops by 20%, combat efficiency drops by 30%, and non-combat attrition rises. Conversely, the combat power boost from that ton of milk far exceeds that of a ton of explosives. It is a coldly rational cost-benefit analysis. In this formula, ice cream is no longer food. It is fuel. It is the lubricant that keeps the killing machine running efficiently. To achieve this goal, the US military faced a tricky engineering problem. At the time, although US steel production was #1 in the world, shipyard slipways were still tight. All high-quality steel had to be prioritized for aircraft carriers and battleships. No one wanted to waste precious steel plates to ship ice cream. Engineers turned their eyes to an ancient and cheap material, concrete, building ships out of cement. It sounds like a fantasy, but in the resource-scarce war years, it was the only choice. These ships didn't need to go fast. They didn't even need engines. They just needed to float, insulate, and carry massive machinery. So, at the concrete shipyards in National City, California, workers began building these ships like they were building houses. Rebar skeletons were erected, and concrete was poured layer by layer. No streamlined beauty, just brutal pragmatism. The hull walls were 15 centimeters thick, not just for structural strength, but for excellent thermal insulation. This in itself was a huge physics challenge. How to make a multi-thousand-ton block of cement, carrying tons of heavy refrigeration equipment, stay afloat without breaking apart in the violent waves of the Pacific. Meanwhile, thousands of kilometers away in Japan, the imperial headquarters was issuing orders for honorable death. Japanese logistics staff were calculating how many grams of rice a soldier needed daily to maintain basic tactical movements. Their unit of measurement was grams. The American unit of measurement was tons. The moment the first concrete barge slowly slid into the water, the outcome of the Pacific War was already sealed. This was not just a crushing defeat in firepower. It was a crushing defeat in lifestyle. It was a dimensional strike of industrial civilization against agricultural civilization. Next, we will go inside this concrete beast. We will see how those oil-stained American GIs, in the heat of the equator, operated complex ammonia circulation systems like alchemists, turning white powder into cold miracles. We will see how this ship, without any defensive weapons, swaggered through waters infested with submarines. This is not just a story about eating. It is a story about how the impossible became the daily routine. Here, ice cream was a currency harder than bullets. It even became the price tag for a pilot's life. To understand why the US Navy valued ice cream more than gold, we have to turn the clock back 30 years. Back to July 1st, 1914. That was the darkest day in US Navy history, at least for the sailors. The Secretary of the Navy at the time, Josephus Daniels, signed General Order No. 99. The content was simple: the prohibition of alcoholic beverages on any US Navy vessel or naval station. Before this, rum and whiskey were the only antidote sailors had against the fear and boredom of the sea. But the moment that pen hit the paper, the Navy went dry. No alcohol, no partying. Tens of thousands of young men were trapped in steel boxes, drifting at sea for months, with nowhere to vent their hormones or stress. This could lead to mutiny. It would certainly lead to a collapse in morale. The Navy brass needed a substitute fast. They needed a substance that was legal, non-addictive, but capable of providing a dopamine reward. They found sugar. Massive amounts of sugar. From that day on, a special area appeared on US Navy ships, the Gerdunk bar. The term comes from the sound a vending machine makes when it spits out a treat. They didn't sell booze. They sold soda, candy, and ice cream. By the time World War II broke out, this substitution was deeply ingrained. For the American sailor of the 1940s, ice cream wasn't dessert. It was a legal drug. It was that tiny slice of normalcy from the civilian world. 1942, the early days of the Pacific War. The Navy Department faced a dilemma. Reports from the front lines were piling up. Heat, malaria, and suicidal Japanese charges were destroying the troops' psychological defenses. Secretary of the Navy James Forrestal famously said, "In my opinion, ice cream is, next to cigarettes, the most important factor in morale." It wasn't just talk. The Navy immediately issued a top priority logistics directive. Ensure that in any war zone, wherever there were American sailors, there must be ice cream. This wasn't just a slogan. It was an industrial mobilization order that would cost hundreds of millions of dollars. But getting ice cream to a tropical war zone thousands of miles away faced a nearly insurmountable physical barrier. There weren't enough transport ships. Although the American shipbuilding industry was running at full speed, every inch of deck space was reserved for killing machines. Liberty ships were packed with Sherman tanks, jeeps, and howitzers. Steel was critically scarce. All high-quality steel was rationed to the Newport News shipyard to build those massive Essex-class aircraft carriers. There was no spare steel to build a ship dedicated to carrying ice cream. It sounded like a dead end. But the Americans found a crazy solution. If there is no steel, use stone. Use concrete. This wasn't a joke. As early as World War I, due to steel shortages, people had tried building reinforced concrete ships. It goes against common intuition. Stone sinks. That's common sense. But in the eyes of physicists, Archimedes' principle has no bias against materials. As long as the weight of the displaced water is greater than the weight of the ship, even a solid block of lead can be made into a boat. So, led by the U.S. Maritime Commission, a project codenamed BRL was quietly launched. Location: National City Shipyard, California. There was no loud banging of steel plates here, no blinding sparks from welding torches. It looked more like a dam construction site. Hundreds of workers were weaving dense meshes of steel rebar. These rebars formed the ship's skeleton. The 9-150 Quartz was the product of this batch, a trefoil-class concrete barge. Total length: 265 feet. Beam: 48 feet. Fully loaded displacement: nearly 6,000 tons. It was a behemoth. The construction process was brutal and hardcore. Workers built huge wooden molds, encasing the rebar cages. Then came the pouring. This wasn't ordinary construction cement. It was a special formula of high-density aggregate concrete that required extreme impermeability and compression resistance. Mixers roared day and night. Grey slurry was injected into the molds like magma. This process had to be done in one go. No stopping. If there was a seam, the hull would snap at the joint under the impact of ocean waves. Workers used vibrators, frantically churning the slurry to expel even the tiniest air bubbles. A single air bubble, under the pressure of high seas, could become the ant hole that collapses the dam. Days later, the molds were removed. What appeared on the slipway was not a gleaming metal warship, but a massive, dusty grey, rough-surfaced monolithic concrete block. It had no keel seams. It was one solid piece. The hull thickness was staggering. The side walls reached 6 inches, and the bottom was even thicker. This wasn't just for structural strength. It was actually this ship's greatest advantage: insulation. Concrete is a natural poor conductor of heat. In the tropics, the surface temperature of a metal hull can reach 140 degrees, requiring massive air conditioning to keep the interior cool. But a concrete hull is like a giant thermos. It blocks out that deadly external heat wave. This made it the perfect cold storage. But that was just the shell. To turn it into an ice cream factory, they had to stuff a mechanical heart inside. Cranes hoisted huge diesel generator sets aboard. Because concrete ships had no propulsion engines, they could only be towed. All their fuel was used to generate electricity. This power wasn't for driving propellers. It was to feed the voracious refrigeration units. Next came the core of the system: massive condensers, evaporators, and miles of cooling pipes. This wasn't just a warehouse. It was a complete chemical plant. Workers laid pipelines inside the narrow concrete compartments. To prevent ammonia leaks, which would be fatal in a sealed ship, every pipe joint was X-rayed. The floors were covered with special non-slip grating. The walls were painted with white anti-mold coating. In an era filled with the smell of gunpowder, the interior of this ship was as clean as a surgical hospital. Meanwhile, in the American interior, another massive logistical mobilization was underway. To fill this concrete beast, the USDA mobilized dozens of large dairy farms in Wisconsin and Minnesota. But this brought another logistical puzzle. Fresh milk is 87% water. Shipping fresh milk across the Pacific is stupid. You'd be using valuable tonnage to ship water. So, dehydration technology stepped in. In processing plants in Chicago, millions of gallons of milk were spray-dried into powder. The volume shrank by nearly 10 times. This was a strategic material. The milk powder was packed into moisture-proof metal cans, then into wooden crates. At the same time, cane sugar from Louisiana and vanilla extract from Madagascar, via Allied controlled zones, began to converge on the west coast. It was a massive funnel. The mouth of the funnel was in San Francisco and San Diego. The tip of the funnel was that concrete barge sitting on the slipway. In 1944, when the first batch of concrete barges was launched, the scene was bizarre. There was no crisp sound of a champagne bottle smashing against the bow. They were afraid it might chip the cement. The sound the hull made entering the water was a dull, heavy thud. It sat deep in the water. It looked clumsy. The Navy receiving officers looked at the manifest with complicated expressions. 2,000 tons of refrigerated meat storage. 500 tons of fresh vegetable storage. And that setup capable of producing 10 gallons of ice cream. No, wait, that's a standard warship configuration. A BRL barge like the Quartz had design specs of producing 500 gallons of ice cream per shift. Running 24 hours in 3 shifts, that's a daily output of 1,500 gallons. Storage capacity, over 4,000 gallons of finished ice cream. This meant that this single ship produced enough ice cream in one day to give every soldier in a full division a double scoop cone. This is the power of industrialization. This is why, while the Japanese Navy was still calculating the caliber of the Yamato's main guns, they had already lost. Because their opponent was using assembly lines and concrete engineering just to make dessert. But the mission of this ship was not easy. It had no power. It was like a giant, helpless whale. It had to be towed by ocean-going tugs at an agonizingly slow speed, about 5 to 7 knots, across the entire Pacific. It was a long and dangerous journey, from San Francisco to Pearl Harbor, then to Eniwetok, and finally to WWII. A voyage of thousands of nautical miles. En route, if it encountered a Japanese submarine, it was a sitting duck. A single torpedo would shatter it. If it hit a typhoon, the heavy concrete hull might sink like a stone, with zero buoyancy reserve to resist the flooding waves. But the US Navy was willing to take the risk. The tugboat captains received strict orders: at all costs, get this concrete brick to the front lines. Because in the eyes of the frontline commanders, the value of this ship was equal to that of an escort carrier. Let's turn our gaze back inside the barge. Imagine the scene inside the hull as this ship bobbed in the Pacific. No portholes, only the cold glow of incandescent lights, the deafening roar of diesel generators, the air filled with a strange smell, diesel fumes, cement dust, the pungent sting of ammonia, and a faint, almost out-of-place scent of sweet vanilla. This is a war zone, but this is also a factory. The soldiers here don't clean guns. They polish giant stainless steel mixing vats. They don't calibrate sniper scopes. They calibrate thermometers. They are the most unique group in Task Force 58. They are called soda jerks. But in the eyes of other sailors, they are gods. When the Quartz finally anchored at WWII Atoll, it was like a giant magnet. It changed the ecosystem of the entire fleet. Before this, supplies were just for survival: fuel, ammo, rations. But now, resupply became an anticipation, a carnival. The arrival of this concrete ark marked the crossing of an invisible threshold for the US military in the Pacific theater. It declared, "We don't just want to win. We want to win with dignity. We want to win with luxury. We are going to eat ice cream while we send the enemy to hell." This extreme surplus of material is about to trigger a mechanical and tactical frenzy in the next chapter. We will see how this barge, with absolutely no mobility of its own, used complex mechanical operations to turn those cold cones into a reason for frontline destroyers to race like madmen. We will go deep inside those roaring machines to witness how the birth of every gallon of ice cream was accompanied by the dangerous scream of ammonia compressors. Now, follow me deep into the belly of the BRL. Pass through the heavy insulated hatch, thick as a bank vault door. Instantly, the tropical heat vanishes. It is replaced by biting cold and a deafening mechanical roar. This is the world below decks. No sunlight here, just the dim yellow halo of explosion-proof bulbs. The air carries a unique scent, a mix of lubricating oil, ozone, and a trace of ammonia. This is the heart of the ship, the refrigeration plant. In the center of the room, crouching like two steel beasts, are the heavy-duty ammonia compressors. These aren't household fridges. They are industrial monsters. Each is the size of half a jeep, flywheels spinning at high speed, emitting a heart-pounding thump-thump-thump. If you look closely, the exposed low-pressure return pipes are coated in thick white frost. Some spots are even frozen solid blocks of ice. Mechanics have to chisel this ice away every hour, or the pipes might crack. Here, the biggest danger isn't Japanese bombs. It's ammonia. In the days before Freon was common, ammonia was the workhorse of refrigeration. But it is also a deadly toxic gas. If vibration cracks a weld and high-pressure liquid ammonia sprays out, everyone in the compartment would suffer lung burns and suffocate within seconds. That's why every operator here has a gas mask clipped to his belt. They are making the sweetest food, but they are constantly prepared for a horrific chemical accident. Shift your gaze to the left. This is the mixing shop. The scene is even more surreal. 4 huge stainless steel mixing vats line the wall. They look like miniature concrete mixers. The operator, a former dairy farmer from Wisconsin, is dumping 50-pound bags of dehydrated milk powder into the hopper. Then comes water. Fresh water, filtered multiple times and sterilized. Then sugar. Finally, he carefully pours a brown liquid from a small bottle, vanilla extract. In this moment, the line between mechanics and cooking blurs. The massive electric motor kicks in. The paddles inside the vat spin violently, making a deep churning sound. Milk powder and water are forcibly emulsified at terrifying speeds. This isn't a craft from Grandma's kitchen. This is fluid dynamics. The timing and speed must be strictly controlled. Too fast, and you get too many air bubbles. It tastes like styrofoam. Too slow, and the ice crystals get too big. It feels like chewing sand. The US military even wrote a 50-page technical manual for this, standard operating procedure for shipboard frozen dessert manufacture. Every step has been quantified into cold, emotionless data. The mixed raw materials are pumped into the freezer. This is the most critical link in the chain. Liquid ammonia at -30 degrees flows through the freezer's jacket. In minutes, the temperature of the mixture plummets. It transforms from liquid into a semi-fluid, ointment-like substance. But that's not enough. At this stage, the ice cream is too soft to transport. It needs to be hardened. At the end of the conveyor belt, 2 sailors are packaging it with lightning speed. They aren't using paper cups. Those are for civilians. This is a war zone. They use 5-gallon cylindrical tin cans. These sturdy, airtight cans were originally designed for paint or lubricating oil. But now, they are filled with vanilla ice cream. Clang! The metal lid is slammed shut. Zzz. The sealer crimps the edges tight. Now, this bucket of ice cream has become a standard military supply unit. It can be thrown, stacked, or even used as a sandbag in an emergency. Subsequently, these cans are sent to the deep freeze in the hold. The temperature there is a constant 10 degrees below 0 Fahrenheit. In this massive ice cellar, created by the insulation of the concrete walls, thousands of metal cans are stacked like walls. This is not just food. This is frozen morale. It is the white gold that will trigger cheers on the deck of a destroyer in just a few hours. Now, let's cut the camera back to the deck. The hardest moment has arrived. Manufacturing the ice cream is only step 1. Getting it to the customer is the real challenge. On the rough Pacific, there are no delivery boys. If you want ice cream, you have to risk your life. The sea is rough. Sea state 4, 2-meter waves. For a 6,000-ton concrete barge, this is nothing. It sits as steady as a brick. But for the approaching Fletcher-class destroyer, it's like riding a wild horse. This destroyer, let's call her the USS Johnston, is executing a high-difficulty underway replenishment. Usually, a destroyer would only risk this for fuel or ammo. But today, the captain authorized this approach just for those few dozen barrels of ice cream. Through the binoculars, we can see the tension on the destroyer's bridge. The helmsman grips the wheel tight, palms sweating. The executive officer is on the bridge wing, shouting bearings through a handheld megaphone. Left rudder 5. Slow to 1/3. Watch the swell. Don't hit her. This is the most dangerous moment. If 2 steel ships collide, the plates just dent, and you fix it later. But the Quartz is made of concrete. It has no elasticity. If the destroyer's sharp bow hits the barge side, the concrete won't dent, it will shatter. Like smashing a biscuit with a hammer. Cracks would spread instantly, seawater would pour in, and this million-dollar factory could sink in minutes. So, an absolute distance must be maintained between the ships. 30 meters. No closer, no further. In these waves, the 2 ships must maintain the same speed and heading. This requires supreme seamanship. Bang! A gunshot, not enemy fire. It's a line-throwing gun. A thin nylon line shoots from the destroyer, crosses the water, and lands on the barge's deck. The barge sailors quickly grab the line and haul over a heavier cable. This is the high line. A steel cable bridge is erected between the 2 ships. This is the logistics stunt the US military was most proud of in World War II, underway replenishment. Even in wind and waves, even while moving, supplies can be transferred like a cable car. Pulleys scream as they grind against the steel cable. A huge canvas cargo net is hooked onto the traveler. Inside are 20 tubs of ice cream fresh from the freezer. Haul away. The bosun on the barge waves a green signal flag. The winch starts turning. The cable snaps taut like a piano string. The cargo net leaves the deck, suspended over the roaring ocean. The water below is raging, and the Bernoulli effect between the hulls creates a massive suction, trying to pull the 2 ships together. The destroyer rocks. The cable goes taut, then slack. If the operators mistime it, the cargo net could smash into the sea or crash against the destroyer's railing. If it were ordinary cargo, a bump wouldn't matter. But this is ice cream. If a tin can ruptures and seawater seeps in, those 20 tubs of precious dessert are ruined. For these sailors who haven't had a sweet treat in a month, that would be worse than losing a crate of grenades. Steady, steady. On the destroyer's deck, dozens of eyes are glued to that canvas bag swinging in the air. It sways like a pendulum to the rhythm of the waves. Finally, in a lull between swells, the cargo net lands precisely on the designated drop zone on the fantail. Thud. A heavy landing sound. Even over the roar of the engines, it's clearly audible. A group of sailors pounces like hungry wolves. They aren't rushing to eat, they are rushing to unhook it and send the empty bag back as fast as possible. Because every second of loitering increases the risk of collision. This action repeats a dozen times until the destroyer's freezer is full. When the last bag arrives, the lines are cast off, and the destroyer accelerates away. Then, you see a sight you wouldn't see in any other military. On the destroyer's bridge, the captain picks up the megaphone. Usually, this is for combat orders. But right now, he yells to that ugly cement barge, "Well done, Quartz. God bless your compressors." Then, the destroyer sounds its whistle. Woo, woo. This is the highest naval courtesy. A warship saluting a supply ship. All for that ton of sugar. Back on the barge, the mechanics, covered in white milk stains and grease, stand on the baking concrete deck, watching the destroyer cut through the waves, leaving a white wake. They don't cheer. They just wipe their sweat and turn back to that deafening engine room. Because the next customer, a cruiser full of wounded men, is already queuing up. The machines cannot stop. The compressors cannot stop. This is how the BRL barge fights. No smoke, no shell casings, only the ceaseless motion of pistons, and the constant output of white calories. But the role of ice cream in the Pacific Theater was more than just food. In certain extreme circumstances, it even became a currency. A hard currency that could buy life. In the next part, we will turn our eyes to the sky. We'll see how high-value ace pilots were priced and traded in this massive ocean casino for a few buckets of ice cream. It is a crazy story about rescue and bounty. June 19, 1944. The Philippine Sea. 15,000 feet in the air. This is the scene of the Great Marianas Turkey Shoot. The radio channels are clogged with static, heavy breathing, and short, sharp tactical commands. Dozens of F-6F Hellcats are harvesting the last remnants of Japanese naval aviation like a scythe through wheat. But even in a one-sided slaughter, accidents happen. A US fighter, call sign Blue 7, pushes too deep into the enemy anti-aircraft screen while chasing a Zero. A 25mm shell slams into his engine cowling. Black smoke instantly spews out, blinding the windshield. The temperature inside the cockpit spikes by 40 degrees in 2 seconds. Lieutenant Jimmy has no time to hesitate. He skillfully blows the canopy, unbuckles, and inverts the plane. Gravity takes over. He falls like a stone toward the deep blue Pacific. Seconds later, a white silk flower blooms in the sky. In this instant, Lieutenant Jimmy's identity shifts. A second ago, he was a hunter piloting a $100,000 war machine. Now, he is the most helpless floating object on the sea. And thousands of meters below, a race for a bounty begins the moment that parachute opens. This is all thanks to an unwritten rule established by Vice Admiral Mark Mitcher, commander of Task Force 58. Or rather, an open secret. In previous battles, Mitcher noticed that while destroyers were willing to rescue downed pilots, the process was often inefficient and risky in rough seas. Destroyer captains would hesitate. Is it worth risking a ship of 300 men in submarine-infested waters to save one guy? It was a brutal trolley problem. To break this psychological barrier, Mitcher, or perhaps a genius logistics officer, came up with a brilliant idea. Put a price tag on life. Not in dollars. At sea, money is just paper. The currency was ice cream. The standard exchange rate. For every pilot rescued, the destroyer could redeem 20 gallons of ice cream from the pilot's aircraft carrier. If the rescued man was an ace or a squadron leader, the price was negotiable. Rumor had it that certain high-value pilots were worth 25 gallons plus 2 bottles of genuine Scotch whiskey. Back to the surface. Lieutenant Jimmy hits the water. The cold sea instantly soaks his flight suit. He quickly cuts the parachute cords and pulls the toggle on his life vest. Then, he makes the most critical move. He pulls the pin on his dye marker. A cloud of fluorescent green dye spreads rapidly in the water, creating a highly visible target 10 meters wide. This is for the rescuers, and supposedly to scare off sharks, though no one has ever really verified if the shark repellent actually works. Jimmy pulls out his signal mirror and flashes it at every black dot on the horizon. He is waiting, but he won't be waiting long. 5 miles from the crash site, the Combat Information Center of the Fletcher-class destroyer USS Kidd. The blip representing the friendly plane disappears from the radar screen. Almost simultaneously, a lookout screams, 2 o'clock, green dye, parachute spotted. The captain's reaction isn't the standard prepare for rescue. It's the reaction of a hound seeing a rabbit. He grabs the intercom and bellows to the engine room, all boilers ahead full. Give me 35 knots. Hard to port. Don't let those bastards on the USS Cotton beat us to him. Yes. This is a competition. On the radar screen, another destroyer is also sprinting toward the crash site at full speed. 2 steel warships are drag racing across the ocean for a soaking wet pilot, or more accurately, for those 20 gallons of ice cream. Black smoke pours from the stacks, blotting out the sun. The bow waves rise meters high. The hulls vibrate violently from the engine overload, making the rivets on the deck groan. This frantic motivation comes from a desperate craving. Destroyer sailors live at the bottom of the food chain. Aircraft carriers have massive freezers, the best chefs, and dedicated ice cream machines. Destroyers are cramped. The fresh water from the evaporators is still warm, and dinner is usually canned Spam. Ice cream? That's the stuff of dreams. So, to them, every downed pilot is just a floating, breathing ice cream coupon. The USS Kidd wins. She uses superior maneuvering to box out the competition. The ship turns broadside to the waves, blocking the swell and creating a relatively calm rescue pool on the starboard side. The scramble nets go down. 2 strong swimmers jump into the water, an act that requires courage, given the shark risk. They swim toward Lieutenant Jimmy. Jimmy is exhausted, having swallowed a gutful of seawater. When the sailor grabs his collar, the first words Jimmy hears aren't "You're safe." They are a shouted, excited roar. "We got him! Strawberry! His strawberry!" Jimmy is hauled onto the deck like a tuna. He is dripping wet, shivering, and in shock. But he is immediately surrounded by warm blankets and hot coffee. The ship's doctor rushes to check his injuries. Meanwhile, the captain stands on the bridge, looking smug, and picks up the TBS radio handset to call the carrier. The following conversation is one of the most dramatic yet routine exchanges of the Pacific War. "Enterprise, Enterprise, this is Kidd." "Go ahead, Kidd. We fished out one of your birds." "Lieutenant Jimmy, condition good, just a bit seasick." "Excellent. Thank you, Kidd. Please return him after the operation concludes." "Roger that. But I'd like to confirm today's exchange rate." There is a second of silence on the radio. Clearly, the carrier captain knows the drill. "Standard rules, 20 gallons. Do you want vanilla or chocolate?" "We want Neapolitan. And, if you could throw in some fresh lettuce, that would be great. Our XO is showing signs of scurvy." "Deal." This scene sounds like dark humor, but the logic behind it is a harsh tactical calculation. This reward system completely revolutionized rescue efficiency. Before this incentive, destroyers might play it safe to avoid submarines. But with the lure of ice cream, destroyer captains became aggressive as hell. They would charge into lagoons under enemy shore battery fire to save a man. They would scrape against reefs in storms, because 300 crewmen are watching the captain. If he abandons a pilot out of cowardice, he is denying his crew the chance to eat dessert. That triggers a crisis of trust. Conversely, if the captain comes back with 20 full tubs of ice cream, he is the ship's hero. He is God. He is Caesar. Days later, the sea is calm. The USS Kidd slowly pulls alongside the massive aircraft carrier Enterprise. This isn't for fuel, and it isn't for ammo. This is a sacred transaction. The High Line is rigged again. This time, sliding over from the destroyer is a showered, reuniformed, and slightly embarrassed Lieutenant Jimmy. He waves to the destroyer sailors from mid-air, and sliding back from the carrier are 4 huge, sealed metal canisters, steaming with cold air. 20 gallons of ice cream. When those metal cans hit the destroyer's deck, the cheer is deafening. It drowns out the sound of flight operations. This isn't food. It is loot. Sailors stand in long lines, holding mess tins, cups, even steel helmets. Each man might only get 2 scoops, but that cold, sweet, melting sensation on the tongue is the only moment in this hellish theater of war where they feel like human beings again. In the carrier's briefing room, this trade is logged. For the US top brass, it is an incredibly profitable deal. Training a qualified carrier pilot takes 2 years and costs tens of thousands of dollars. 20 gallons of ice cream? Cost less than $50. Trading $50 of sugar water to recover a priceless combat asset and boost the morale of a destroyer crew is an economic miracle of war. But there is another side to this story. Pull the camera up again, above the horizon, into the eyes of the Japanese pilots peering through the clouds. What do they see? They see American destroyers breaking formation and sprinting at full speed just to save one man. They see American carriers, in the lull of battle, conducting this seemingly militarily useless supply transfer. They cannot understand it. In the Japanese code, being shot down is a disgrace. Survival is shameful. Pilots are supposed to scatter like cherry blossoms. There is no such thing as a search and rescue system, let alone using precious strategic supplies to buy back a defeated warrior. The gap in values here is wider than the Pacific Ocean itself. However, the influence of these ice cream tactics didn't stop there. When this gap moves beyond just visuals and becomes a tangible experience of touch and taste, the destructive power it generates is more terrifying than a 1,000-pound bomb. In the next part, we will walk into a POW camp. We will open the diary of a Japanese commander. We will see how, when a captured Japanese colonel was served a bowl of ice cream on a US warship, his mental world collapsed. We will witness how this ice cream barge delivered the final blow, not shattering the body, but shattering the soul. August 1945. Waters near Okinawa. On the deck of a US heavy cruiser, a special passenger awaits the judgment of fate. He is a Japanese colonel, captured just recently in a desperate tunnel defense operation. His sword has been confiscated. His uniform is tattered, yet the collar is buttoned tight, maintaining impeccable discipline. His eyes are filled with a dead, ashen despair and a twisted sense of pride. He is ready to face torture, a firing squad, or even the treads of an American tank. In his mind, he has rehearsed 1,000 heroic deaths, determined to use the last of his Bushido spirit to shame these American cowards who only know how to rely on machines. However, there is no torture. A young American private first class approaches him. In his hands, he carries not an instrument of pain, but a stainless steel tray. On the tray sits a metal cup filled with 3-color ice cream, chocolate, vanilla, and strawberry. It is still steaming with cold air, condensation beading temptingly on the side of the cup. The colonel freezes. He thinks this is some new form of psychological torture, or perhaps a last meal before execution. He looks warily at the young soldier. The soldier simply shrugs, points to the cup, and says in broken Japanese, "Eat. Good." The colonel's hand trembles as he picks up the spoon. He hasn't tasted sugar in 3 years. For 3 years, he has eaten lizards in the jungles of New Guinea and chewed on leather belts in the caves of the Philippines. When that first bite of cold, sweet, smooth cream melts in his ulcer-ridden mouth, the sensation is more violent than any bomb explosion. Not because of the taste, but because of the fear. A deep, desperate fear that penetrates his very bones. In that instant, he realizes a fact that collapses his entire worldview. Here, at sea, 8,000 kilometers from the American mainland, in a war zone where both sides are bleeding, his enemy still has the capacity, the resources, and the leisure to provide frontline soldiers with this easily melting luxury. What does this mean? It means the American supply lines haven't just not been cut, they are overflowing to the point of excess. It means the Americans aren't viewing this war as a battle for survival. They are calmly managing a war. While the Japanese Empire is confiscating civilian brass statues to make bullets, the Americans are wasting valuable shipping tonnage to transport vanilla extract. This isn't war. This is bullying. This is a brutal, all-encompassing humiliation of an agricultural, artisanal civilization by an industrial one. According to the memoirs of many Japanese POWs after the war, this kind of psychological breakdown was not uncommon. For years, the Japanese military indoctrinated its soldiers with a single idea. Americans are soft, rich boys who crave pleasure. Once their supplies are cut, once they have no coke or steak, they will surrender immediately. The Japanese, possessing the Yamato spirit, possess a spiritual atomic bomb that allows them to endure hunger and pain, ensuring victory. It was a delusional faith built on the idea of spirit over matter. But when that concrete ice cream barge, the 9-150 Quartz, appeared in the Pacific, it was like a heavy slap across the face of that faith. It silently declared, spirit might be noble, but in the face of absolute material superiority, spirit is powerless. If your enemy can industrialize the consumption of ice cream, what do you have left to win with? Let's take one last look at this concrete monster. It is not just a ship. It is a massive metaphor. It represents the core logic of the American victory in World War II. Logistics is combat power. In the eyes of many military enthusiasts, war is ace pilots dogfighting in the sky or tank commanders flanking on the ground. But in the eyes of strategists, war is math. It is tonnage, it is calories, it is productivity. The victory of the US Navy wasn't just because they had more aircraft carriers. It was because they built the most complex global supply chain in human history. In this chain, ice cream was as important as 16-inch shells. Why? Because war is fought by humans. Machines may not tire, but humans do. In tropical war zones, the pressure of heat, disease, and death rapidly drains a soldier's mental health bar. The Japanese method was extraction, using harsh discipline and spiritual brainwashing to forcibly keep soldiers functioning until they broke. The American method was recharging, using ice cream, movies, hot showers, and mail to constantly restore the soldier's blood. This ice cream barge was essentially a giant psychological charging station. It restored combat effectiveness right on the front lines for soldiers who would otherwise need to be sent to the rear. It drastically shortened the rotation cycles of carrier groups. This is a brilliant soft tactic. It turned making soldiers feel good into military efficiency. Looking out from the deck of the Quartz, we can see the prototype of modern warfare. This ship set a precedent. Soldier comfort is no longer a gift, but a component of combat power. Since then, US logistical standards have become the ceiling that global armies look up to, or even mock. In Vietnam, US helicopters delivered ice-cold beer. In the Gulf War, the US built air-conditioned Burger Kings in the desert. The source of all this can be traced back to that concrete barge in 1945, belching black smoke, deafeningly loud, and churning out vanilla cones. The war ended. The Quartz and her sister ships weren't preserved as museums like the battleship Missouri. They were too ugly, too unremarkable. After the war, they were abandoned, auctioned off, or scrapped. Some became commercial cold storage. Others were towed to unknown beaches and grounded to serve as breakwaters. Their cement hulls slowly peeled away under the erosion of the waves, revealing rusting rebar skeletons. The once roaring ammonia compressors have long since fallen silent, becoming homes for fish. History seems to have forgotten them. People only remember the mushroom cloud of the atomic bomb or the moment the flag was raised on Iwo Jima. But if you ever have the chance to dive to the bottom of certain atolls in the Western Pacific, in the gloomy depths, you might still see a massive, square concrete wreck. It lies quietly, covered in coral and sea anemones. It no longer produces sweetness, but it is a monument to overkill. It proves that in that crazy era, there was a nation that, to win a war, not only built bombs to destroy cities but also built a floating ice cream factory. It tells us, when the machine of war runs to its extreme, the most absurd things are often the closest to the truth. Because in war, the greatest terror isn't death. It is gnawing on tree bark while watching your enemy sprinkle chocolate chips on their ice cream. That is a defeat more total than death. Next time you open your freezer and take out a tub of ice cream, take a moment to think about the Quartz floating on the Pacific. Think about those young sailors driving destroyers at full speed through a hail of gunfire, just for that taste of sweetness. So, if you were a fleet commander at the time, would you have approved the construction of such a ship? Or would you think it was a pure waste of resources? Do you think that in war, letting soldiers eat well is really more important than manufacturing one more bullet? Please leave your thoughts in the comments section. I'd love to see the discussion. If you enjoy this kind of hardcore, obscure, and slightly philosophical military history content, please make sure to subscribe to my channel and hit that notification bell. It means the world to me.